contained in E. So basically we have to prove that this is the largest congruence on S contained in E. We have to prove this. First we have to prove that E natural is congruence on S, and then we have to prove that it is the largest congruence. So first we have to show that E natural is contained in E, because E natural is the largest congruence on S contained in E. We have to prove. So proof. Take any A comma B belongs to E natural. Correct. It implies that. What does it imply? It implies that XAY comma XBY belongs to E for every xy belonging to S1, correct? So it implies that 1 into A into 1, 1 into B into 1 again goes in E. That is A comma B. It implies A comma B belongs to E. So it implies that E natural is contained in E, correct? Now we will prove E natural is equivalence relation. So to prove E natural is equivalence, we have to prove E natural is reflexive, it is symmetric, it is transitive. So I think when E is equivalence, correct, isn't it? You see XAY comma XBY, XAY comma XAY. Belongs to E for every xy belonging to S1. XAY comma XAY comma XAY belongs to E, since E is what? Reflexive. So it implies what? It implies that A comma A. You also write here for every xy belongs to S1 and for every A belongs to S. So it implies that A comma A belongs to E natural. So it implies that E natural is what? Is reflexive. E natural is what? A reflexive relation, because A comma A belongs to E natural for every A belonging to S. So E natural is reflexive. Now we prove E natural is what? It is symmetric. After that we have to prove E natural is transitive. Take any A comma B belongs to E natural, correct? It implies what? It implies that xay comma xby belonging to E, where x comma y belongs to S1. It implies that xby comma xay belongs to E, xy belonging to S1. Correct. It implies what? B comma A belongs to E natural. So it implies that E natural is what? Symmetric. Of course, it is for every xy belonging to S1. So we have shown that E natural is symmetric. Now finally we show that it is transitive. So for this we take it implies what? When B comma C, it implies that xay, xby and xby comma xcy both goes in E for every xy belonging to S1. Now see, E is what? Equivalence relation. It implies what? E, so being equivalence, it is transitive. So xay comma xcy goes in E, since E is what? Transitive. For every xy belonging to S1. It implies what? A comma C belonging to E natural. So in this way, E natural is what? Transitive. It implies that E natural is what? Equivalence relation. Equivalence. Correct? Now we have to prove that it is right compatible as well as left compatible. Now take any E comma A comma V belongs to A comma B belongs to E natural. It implies that xay comma xby belongs to E for every xy belonging to S. Correct? Now in order to show CA comma CB, what we have to do? Now for any C belonging to X, if we calculate XCA comma XCBY, if we calculate this, so it is what? It is equal to XC into A into XC into B into Y. Of course, it will go in where? It goes in E, because you know that XAY, XBY, it's true for every, these n elements should be from S1. So it belongs to E since XC comma Y is from S1 and A comma B is from E natural. Correct? So it goes in E. Now if it goes in E, it means what? XCA comma XCBY goes in E. X into CA into X into CAY into X into CBY goes in E, where XY belonging to S1. So it implies what? It it implies that CA comma CB belongs to E natural. It implies that E natural is left compatible. Now all of you can prove by yourself that E natural is also right compatible in a similar way. Just you find out the value of XACY comma XBCY and prove it. So E natural becomes congruence. Congruence on S. Now let T be another congruence contained in E. Correct? T be another congruence contained in E. Now what is claim? T is contained in E natural. Correct? Claim is that we have to prove that E is it is the largest congruence. Largest congruence means here. Yeah, correct. It is correct. Now take any C comma D belongs to T. Then T is contained in E. It implies that C comma D belongs to E. Correct? Now you see we have taken, see T is a congruence, so we take AB. It implies that XAY comma XBY also goes in T, and T is contained in E. Since this is for every XY belonging to S1, since T is left and right compatible, because T is a congruence, so T is compatible, left compatible, right compatible. So XAY comma XBY goes in T and goes in E. So XAY comma XBY goes in E for every XY belonging to S1. It implies what? It implies that A comma B goes in E natural, and it implies that T is a subset of E natural. So in this way we have proved that E natural is the largest congruence on S, semigroup S, contained in E. So in this way theorem is proved. So this is all about today's lecture. So we stop here and complete the notes by watching all video lectures. Make notes. All of the students have to make the notes. It is mandatory for all the students to make the notes by watching video lectures. Thanks all.